So we kind of talked about this idea. It says, hey, if I've got this present, the wrapping paper nowadays comes with these square grids on the other side, and you can figure out the total number of squares it would take to completely cover the gift, right? Now I understand that when you wrap stuff, there's overlap going on, right?
Yes.
We just want to know how many squares it would take to completely cover one of these prisms or pyramids without overlap. Okay. So everybody on up here, everybody has the notes, yes? As I was walking around, it sounded like you guys had a pretty good handle on what it meant to have surface area or find a number of square inches on here. Now again, are all the sides just rectangles? No, you got to take into consideration some of the sides might be a triangle. Okay. So right up here, let's go ahead and say 9.5. We're going to be dealing with surface areas of space figures, our case prisms. We'll calculate the number of square units on what's the big word right here? On the outside of prisms. How many squares it takes to cover the outside. How many of you guys have ever painted your room before? If you guys just go buy the paint, if I had leftover paint, good enough. Couldn't you read in there and say, hey, a certain amount of paint covers so much area? Couldn't you have measured out the space on your wall and use that to figure out how much paint you should buy? Okay? If you're like me, I just go buy the paint. If I run out, I go buy more. Right? Okay. Well, guys, in order for this to work, we first of all need to understand what a prism is. Guys, all a prism is the following. Prisms like this, it's just kind of like, notice this triangle and this triangle. Are these two triangles on this right here the same or different?
Same.
Front and back are the same. Okay, prisms basically are going to see shapes where the bases are the same. So if I stand this up, can you stand it up such the top and the bottom are exactly the same? Is there such a way I can stand this up such that the top and the bottom are exactly the same?
Yes.
The answer to that is yes, top and the bottom are exactly the same. It's a prism. Now, how about this one? Can I set this in a certain way such the top and the bottom are exactly the same? They are. How about this way?
Yeah.
Is that a prism?
Yeah.
Okay. How many of you guys out there have something that's not a prism? Anybody have a prism or a shape that you can stand up but the top and the bottom aren't exactly the same? Kyle, hold yours up. If I hold that, if I set that on any side, will the top and the bottom ever be the same? No. So can that be a prism? Got to be some kind of a pyramid, all right? Grant, hold yours up for me real quickly. Are the top and bottom ever going to be the same when I set that down somehow?
No.
Absolutely not. So is that a prism? Be some kind of pyramid. Yeah, like a pyramid. Okay. So you understand the difference between pyramids and prisms, first of all. Okay, very good, thanks. All right, so let's get rolling here. Guys, we need to understand some basic formulas. So rectangle. What's your rectangle formula again? Base times height. Jot these down one more time. Get them etched in our memory. Base times height.
Stop.
Mariah, I believe you had the trapezoid nailed. What was that again?
Half your base, 1 plus base 2 times your height.
Okay, make sure you got that down. All right, somebody shoot the triangle for me.
Half your base times your height.
So say that one more time.
Half your base times your height.
Half your base times height. Okay, how about a circle?
Or pi r squared.
Pi r squared. Keeping in mind pi is what value? 3.14. How about half a circle? Full circle. The full circle is 1 pi r squared. What's half a circle?
2 pi r squared.
Not 2 pi. Go the other direction. Wouldn't that be 1/2 times pi times r times squared? Guys agree? We talked about half a circle much. Pi r squared times what? Times half. Okay. Are we good?
Yes.
Okay. Just double check. Make sure you got the formulas down. Guys, I think if I understand you correctly, our job is to find the total number of square units on the outside here. So, I guess I'm going to come up to the group here that has, let me see what I've got here. First one's a triangle, isn't it? Hey, who had the one that looked like that? Who had that shape? Who had that shape?
That group. No, wait, that's the
What's
square.
on the back side of your,
Brianna.
what's on the back side of your board?
Mine?
Yeah. Show me. Now. I want to erase that. We'll chat at the end of the hour, okay? All right. Where is my triangular prism people at? Who wants to be a spokesperson for the group?
I will.
Brianna, come on up here. Bring your shape, bring the ruler. Okay, Brianna, first question I'm going to ask you. As a triangular, first of all, why am I calling this a triangular prism? Anybody have an idea why?
Because at the ends are zigzag triangles.
The ends are triangles. Now, guys, again, notice right here, if I set it on this side, are the top and the bottom exactly the same? Well, wait a minute. Now, when I set it on this side, that's going to become my bottom? It's kind of like me. When I sit on my bottom, I'm a prism because my bottom and my top, same thing. Button head, butt head, right?
Yeah, that's hilarious.
You can do it though, right? Is this bottom the same as the top right here? It's not, okay? How about when I sit it this way? Are the bottom and top the same? Okay, the prism is named on the shape that you can sit on the bottom and top that would be exactly the same. So if I sit it on the triangular side, isn't the top also a triangle? You guys agree with that? So this is a side where the bottom and the top would be exactly the same shape. And what shape is that? Triangle, right? So we call it triangular prism. Okay, Brianna, how many sides do you have to this? Okay, you're in charge right now. Tell me what you guys did with your measurements, first of all.
Measure the rectangle base times height.
So I'm going to kind of highlight some stuff. You might want to do the same. Watch what I do here. This is going to get kind of weird. If you stare at these long enough, they're going to change on you. You're going to get weirded out a little bit.
Oh, they just
Okay.
did it. Oh my goodness.
So you measured the bottom. Is that what you said?
Yes.
Okay, so like this bottom, the way it's sitting. Kind of hold this like this is sitting, okay? All right, so she's saying she's measuring the bottom right here. So let me make some notes here. Here's the bottom right down here. Do you guys see my bottom? You guys okay with my bottom? Guys okay with that bottom right there? Okay, I like to make notes when I'm finding surface area. Again, we're adding the area of all sides, right? Right?
Right.
Bottom. And don't take that out of context, please. What shape is the bottom? Good. Who said round? Ezra? I said, oh, don't take it out of context, boys. Okay? Rectangle, right? What were your dimensions on that? You remember?
3.5 and 5.
3.5 by 5.5. Okay, so I want you guys to write that down. 3.5 by 5.5. Now, it might be a good idea to turn any fraction into a what this section? A decimal. Okay, since the bottom is rectangle right here, how am I going to find the area of that bottom? Length times what? I'm going to go 3.5 times what here? What'd you guys get for that, Brianna? 19.2. Okay. Okay, why'd you times that by 3? Okay. Look at her shape again, everybody. Brianna just said she's going to take 19.2 times 3. Why is she multiplying by 3? Because all three of these rectangular sides, it's a what kind of triangle did you say? This triangle, what's true when all three sides are on this are the same? What's the name of that? Equilateral, very good. Okay. So the bottom rectangle, do you guys see this slanted rectangle I'm pointing at? And this slanted rectangle I'm pointing at? Well, they're all going to be the same is what Brianna's saying. So I'm going to say, hey, I've got this side right here. And then the back side right here also. This is going to get kind of goofy. But you're going to times that by 3, right? That's the 3 rectangular sides, which is how much? 57.6? Okay, so we've accounted for the 3 sides. Anything else? Okay, the triangle. The way this is sitting is like this. Can I hold this again? Don't you have a front triangle and a back triangle the way this is sitting?
Yeah.
Front and a back? Okay. She's saying that there's a front and back triangle, so I'll say, well, okay. Front, the back. Both are triangles, right? Okay, Brianna, carry on.
Then we measured the base, which was 3.5.
So the base is 3.5 here.
Divided by 2.
Okay, and divide that by 2. How about the height? What did you get for the height right there? 3? Okay, so for this right here, the front, which is what kind of a shape again?
Triangle.
Front is a triangle, right? Okay. And that area would have been 1/2. Oops, that's a bad looking 2. Would have been 1/2 times 3 times 3.5, right? How much?
10.5.
7.5? I still didn't.
10.5.
10.5. 10.5. You gotta cut that in half, so. Okay. I know the 10.5 is gonna come from 2 sides. That makes sense. So I'm gonna cut this in half, which would be, the front is 5.25 when I do that calculation. Which makes the back then. The back is the same, isn't it? What's that gonna be? 5.25. Okay. Let's see, the 3 sides had how much area, gang? 57.6. The front triangle was 5.25. The back triangle is 5.25. What do I want to do with all those numbers then to get the surface area? Add them together, right? So I've got 57.6. That's the 3 sides plus the front, which is 5.25. And how much was that again, Brianna? 68.4. Wouldn't that be 68.1? I think? 68.1 square units. In this case, we measured in inches, right? Very good. Very good. 68.1 square inches. All right. Again, you just find the area of all sides. Are all sides in the same? The answer is no. You gotta figure out what formula to apply to each side. Once you know the area of each side, it's just a matter of taking all those numbers and doing what? Adding them up. Okay? Adding them up. Thank you, Brianna. I'm gonna have you guys try one on your own. I want to kind of visualize this. First of all, do you have this down? Everybody have that down? Excuse me. Let me know when you're ready. Megan, did you get it?
Yeah.
Like everybody else have it? I saw a few pencils running out there. Britt, you got it?
Yeah.
Okay. Let's look at the next one here quickly. So I have a rectangular prism. Who's got a rectangular prism out there right now? Okay, hold that up. Why is it a rectangular prism? I can set the bottom down as a rectangle, right? And the top rectangle would be exactly the... I could also call it a square prism. How would it be if it was a square prism? There you go. Make sense? Alright, I'm going to put some dimensions to this. You guys don't really need to give me yours on this. I'm going to put some dimensions to this. I'm going to count on you 3 people to go around and help them out if they have questions, because you know what to do on rectangular prism. You're my rectangular prism experts. Okay? Here we go. Let's go 10 inches this way. Let's go 4 inches this way. And we'll say 6 inches of height. Now guys, it might help you. It might help you if you draw these lines in here like I'm about to do. Okay? Now this doesn't by any means mean that this is the say-all end-all, but I think this would help if you could draw some dotted lines in this and give this some perspective. So watch what I do here. I'm going to do this. La la la. La la la. Does that help you visualize it a little better? like the front and the back. Can you guys see that a little better now? What I'm pointing at down here is the bottom. Right here is the front. This is the top. This is the left side. This here is the right side. This is the bottom. Okay? All right? I want you guys to see, first of all, where are my rectangular prism experts again? How many sides to that? There's 6, right? Kind of describe to me all of your sides, you 3. There's a 4 rectangles and 2 sides. Now, guys, careful on this. The ends that were squares right here, is this square, the shaded end, is that square anymore? No. Okay, watch what I do. Do you guys agree that there's a top and a bottom to this? What's the dimension of the bottom? 10 by what? 4. Okay. You guys agree there's a top and a bottom, right? So I'm going to write the word, oh, I don't want to do that. Come on, Parson. Let's go bottom and top first. I'm going to write this down. Bottom, top. Okay, can I borrow your rectangular prism?
Yeah.
You guys agree there's a bottom and a top, right? Okay, see I'm holding this. There's also going to be a front side right here. That's the front side that you see. Also then, the side that you don't see is the back. There's a front side and a back side, right? Front side. And a back side. And then the way it's also positioned to you guys, there's also a right side and a left side. So how many sides totally? Okay. So what I suggest, get down all the sides you've got to figure out areas for and work with it. So I'm just going to highlight the bottom. What's going to be true about the bottom and top in a rectangular prism? It's going to be the same. So I'm just going to highlight the bottom down here. Let me do that. Let me just highlight your bottom down here. Boom, boom. Okay, bottom right there. You guys see the bottom? Everybody see it? What's the dimension of the bottom? What by what? Keeping in mind that's what kind of shape. It's rectangle, right? So you're just going to take 10 times 4, aren't you? 10 times 4, which would be what? 40. So 10 times 4 looks like the area of that bottom. Okay. Lainey, what did you guys discover in your group about the area of the bottom as it relates to the area of the top? Same thing. So when I take this right here, move this up, I should be able to move that up. Isn't that going to be the same as the top right there? It is, isn't it? Okay, so what's the area of the top have to be in that rectangular prism? 10 times 4 again, how much? 40. And if I go back to this right here, they had explained this, said, hey, in this right here, we had some multiplication going on in the work that they used to discover how many square inches were here. They said, well, I multiplied by 2, or in this case they multiplied by 4 because all 4 of these sides were the same. Here I'm saying that not all 4 sides are the same, but we can at least identify that the top and the bottom are the same, right? So if the bottom again was 40, which I forgot to write down here, the bottom is 40 square inches. What'd that make your top? 40 square inches as well, right? All right, so let's get rid of this bottom and top stuff. And get rid of this. Let's talk about the front and the back. So the front and the back, here's my front side. Okay, this is where things get kind of difficult for kids at times. Visualizing the distances. First of all, that's a rectangle again, isn't it, in the front? What are the dimensions in the front? 10 by 6. So since it's a rectangle for the front, what are you going to do? 10 times 6, right? That'll be 60 square inches. So just as I have the front in a rectangular prism, what's going to be true about the back of that then? It's going to be the same. So let's move that to the back. Oh my. Pretty close, right? You guys get that? Make sense?
Yes.
Okay, so the back is also going to be how many square units? Okay. All right, so lastly here then, whoops, we've also got to deal with the left and the right. So the the right side here is kind of shaded in for us already. What are the dimensions of the right side? 4 by 6, which that means this is also going to be 6 by what? 4. Okay, have I accounted for all 6 sides then? Well, the left side would be 6 times 4, which is how much? So each side here is 24 square inches. Guys, let me check. How many sides did we have? How many areas should I have? To get total surface area, what do you want to do? Add them all up. Add them all up. Okay. In which case, I have no idea. I'll try and beat you. I got it. 248. Taylor's on her A game today. Blew me away. 248. What kind of a unit would I like to attach to this? 248 square inches. By the way, what did you guys get for a value? Did you get 96 on that one? Got 96? 90. Okay, good. Good. I'd buy that. So I'm guessing your dimensions were 3s and 6s. Yes?
I think so. She did all.
3s and 6s? Good job, guys. Give yourself a pat on the back. All back. There you go. All right. Guys, is this kind of tedious?
Yeah.
Time consuming? Yeah? Is it impossible? It's actually pretty darn easy, isn't it? Okay. All right, so let's look at another example. So not everything was so easy. I think the next one that we looked at here, Mariah, was your group first of all able to come out with an answer?
No.
Did you have a thought to it though?
Well, we had the find the top and the bottom and then add it together.
So you understood that the top and the bottom was a circle, right? So I think if I understand you correctly, first of all, what's the name of that shape? Cylinder. Okay, yeah, you're exactly right. And the cylinder is pretty interesting. So, Mariah, I just want to take notes here real quickly from what you had done. So it looks like to me you said, hey, I've got a top and a bottom, which are circles, right? So we have a top circle, and you have a bottom circle, right? Okay. What part was hardest for you guys to figure out an area on?
Probably the center piece.
Okay, so the side, basically, right? Can I see the cylinder real quickly? Okay, so what we're saying is this. It's pretty easy to find the area of these two circles on front and back as I've got position. We're top and bottom now, right? The hard part is, how in the world do I figure out how many squares go around this side right here? Okay, how do I find how many squares go around this right here? I want to show you something quickly. Yeah. Guys, watch. This is kind of like the side around here, right? If I could take this side of the can and just cut right here, see what I'm going to do? I'm cutting on the back side here. Cutting on the back side here, I'm going to cut that side out and tear it out. When I take that side out and tear it out, what kind of shape is formed there for you? It's a rectangle, right? Wouldn't that rectangle's height be the same as the height of this right here? Would be, right? Problem would be, how do you figure out this length right here? Wasn't that length right here that came from around here going to be the same as one revolution around here? It will be, won't it? Okay? So here's the deal. We agree that the top and bottom are both circles, right? If I could cut a line right through here and then unfold that, what kind of shape would this side unfold to be? Or I should say, it's not folded, it's rounded. How would I? Flat. If I wanted to flatten it out, it'd be a rectangle, right? Okay. I've got good news about cylinders. You want to hear it? I can make cylinders very easy or very difficult. What would you like me to do?
Easy.
Side that's a rectangle. Okay. Cylinders are nice because they have a formula. They have a formula to be able to allow you to find the surface areas. I'm going to kind of dissect this formula to try and help you with this. First of all, I want to go back to Mariah's group and say, yes, you guys are exactly right. The top and the bottom are both what? Top and the bottom are both what? Circles. So here's how we're going to do this. Here's how we're going to do this. I'm going to have kind of a two-step formula to do this. Whoops. Mariah, can I come back to you? What was the area formula for your circle again? Just tell me, just a circle.
Pi squared, or pi r squared.
Pi r squared. Step one. Watch what I do here. Pi r squared, where r represents what again?
The radius.
The radius, right? Okay. How many circles were there to this, though? Two. Okay. Step one is going to allow us to find the total surface area of the top and the bottom in this case. Two circles. Top circle, bottom circle. Okay, are you with me on that? Okay, then, step two. I want you to do this. And I'm going to make this as easy as possible, okay? That's what you want, right? Step two, write this down, right? Pi d h. Okay, now the DH doesn't stand for the hitter in the best league in baseball. Okay? Okay? We understand what pi is, right?
Yeah.
What do you think the D stands for? Diameter. Diameter of the top, right? Guys, pi times diameter is the circumference of a circle. Pi times diameter, that's this distance around. And then, what do you think the h stands for? If I take this pi d, the distance around here, times the height, this here, oh my goodness, this distance up top here is my circumference wrapping around those circles, my pi times diameter right here, going across. You guys see that? This here is my height right here. So you guys see pi times diameter is my distance going around after I unfold that. This here is my height, so what would you do with this and this to get an area of this rectangle after you unwrap it or flatten it out? Okay, so here's what we're going to do. We're going to throw some numbers to this. I'll give you a radius. In fact, Mariah, this is your group, so what do you want your radius to be? What was the radius in here, remember? Measure it for me real quickly. Can you catch this? This is just like my beanbags. I'm the beanbag champion on Roll Road. Anybody that wants to come take my trophy, I dare you.
Alright, let's go.
Game on, buddy.
Game on.
Boom! What's the radius on that, Mariah?
4.5.
4.5. Let's round. Let's go 5. Let's call it 5, okay? How about 5 inches? How about measure the height on that for me real quickly? What's your height there? 6 inches. Okay. This is the one where we want to find out how many square units cover this whole thing. Okay? Now again, I'm advising, let's do this in 2 steps. Okay? Let's find our step 1 number. This here, step 1, represents the top and the bottom. That's step 1. Okay, and then find the side. That's going to be step 2. What are you going to do with step 1 and step 2 once you have your numbers? You have total surface area. What are you going to do when you have your numbers? Won't you add them? Okay, so let's roll. Step 1. Let's do step 1. Ooh, I like that color. Step 1. What's step 1 advising that we do? 2 times pi being what value? Times the radius squared. Let's see, when I take the radius squared, that means take 5 times itself, doesn't it? Isn't that my 5 squared part right here? Isn't this my pi value? So, I don't know what that is. 157?
Yeah.
157?
Yeah.
Okay, so step 1, I get a value of 157. Again, this is my 2, part of the step. This is my pi value. This is my radius squared right here. The 5 and the 5 is radius squared. You guys agree there?
Yeah.
Agree? How about step 2? What's step 2 asking us to do? Pi times, say it again, Scott. Okay, so what would the diameter be in this? If the radius is 5, what's that make the diameter, Scott? So I'm going to go 3.14 pi times the diameter, which is 10, times the height, which is 6. Okay? Somebody punch that up for me. One 188.4. Okay, so that'll be the side of it. Guys, the 2 top and the bottom, the 2 sides, the 2 circles, 157. The side, 188.4. How are you going to total this up now? What are you going to do? So my surface area, which I'll abbreviate SA, 345.4. Is that what you're getting? 345.4. Again, measured everything in inches, so as we're dealing with what's the area, what kind of unit is attached? Square inches, right? What do you guys think? Again, I think the work is kind of tedious. I think it's pretty easy. It's work, but it's not difficult, right? You guys agree with that? It'd be like in some great big business, somebody probably needs a staple puller out of big documents, right? Somebody probably has a job to pull staples out of documents, right? Sound like fun? Necessary? Okay? It's kind of what's going on here. All right? Well, let's see what the next example is. Does everybody have that down for me, first of all? Everybody have that? All right, let's just double check and see what we have on this next one. Ew.
What is that?
That looks like a block of gold to me. You ever seen those blocks of gold before? It's kind of what it looks like.
It's like a little longer one.
Yeah. I've got about 20 of those laying at home.
Same. But they're diamond though.
Fine, I have one like that. Problem is, it's plastic painted gold.
Yeah, I was gonna say.
Gosh, you know what? Let's get this dimensioned out. Let's get it dimensioned out today. We're not going to get through the last 2 examples, but let's get them dimensioned out so we can pick this up quick tomorrow and I can give you some time to work. This one's really goofy. This one's a tough one. I'm going to label this 12 inches right here. I'm going to tell you this distance back here is 8 inches. I'm going to tell you the depth here will go 20 inches this way. And then I'm going to sneak a height right here on this trapezoid. Let's sneak that height in there of 5 inches. Okay, so double check. You should be putting 4 dimensions to this right here today. 12, 5, 8, and 20. Make sure you get them in the appropriate spot. I want to dimension the last one as well. So get that last one out. We'll dimension that out, and we'll call it a day here today, all right? Does anybody have any more time with the dimensions right here? All right, let's take a look at the next one here. Let's just get this dimensioned out. This one's really bad. I'm going to call this 6, 6, and then I'm going to put a height right here on the slant height, and I'm going to call this 9. Okay? So you guys make sure you have those for me tomorrow, and we'll pick this up tomorrow. Any questions about what we've done today? Okay, bring your stuff with you tomorrow. We'll finish it tomorrow, all right? No, I'll give it to you tomorrow. What you want today?
I'm